Hello, my name is Ram and welcome to another video of Matuklasan. If you're new to my channel, please check the playlist below so that you would know more about logic and other related contents of math in the modern world. And in this video, we'll talk about the truth values of compound propositions and how to construct truth tables. A truth table is a mathematical table showing how the truth or falsity of a proposition varies with that of its components. And it looks like this. I know that it's quite difficult to absorb it right now, so we're going to start with the basic ones. For the operator negation, its truth value table looks like this. So we can see here that if the proposition is false, then the negation is true. While if the proposition is true, the negation is false. For example, let P be the proposition 9 equals 3 plus 5. Now, we all know that 9 equals 3 plus 5 is false. So, the negation of P now is true. But how are we going to prove it? Okay, so P is 9 equals 3 plus 5. So, if we're getting not P, then this proposition will become 9 is not equal to 3 plus 5. We all know that the truth value of this is false, right? But if you will get the proposition of this statement, then 9 is not equal to 3 plus 5 will become true, right? In the previous video, we studied 6 different operators. So what's next after negation? Yes, it's conjunction. Conjunction is supposed to summarize what happens when we use the word and in English. So for P and Q to be true, both propositions P and Q should be true. If one of these is false, like these three rows here, then the compound statement is false as well. For example, let P be the proposition 1 plus 4 equals 5. Q be the proposition 3 times 4 is 12. Now, what is the truth value of P and Q? We all know that the value of P here is true because 1 plus 4 is really equal to 5. 3 times 4 equals 12 is also true. So we can see here clearly that P and Q are both true. So what is the answer if the two propositions are true or are both true? Okay, you can see here that if they are both true, then P and Q here is also true. On the other hand, if P is false and Q is true, then the answer or the truth value is false because one of them is false. In disjunction, at least one of the propositions should be true for the compound proposition to be true. So here, T or T is true. T or F is true. F or T is also true because at least one of them is true. And it will only be false if there is no true value for each of the two propositions. So F or F is false. For example, what is the truth value of the compound proposition 2 plus 2 equals 4 or dogs can fly? Now, let this proposition be P and this proposition be Q. So, since this is OR, we are looking for P or Q. Now, the truth value of 2 plus 2 equals 4 is true because that is correct, right? But we know that dogs cannot fly, so this is definitely false. So, true or false will always give us a truth value of true because this is true. Exclusive OR is different from disjunction because here only one proposition should be true. If they are both true, then the truth value is false. Likewise, if they are both false, then the truth value for P, X, or Q is also false. For example, what is the truth value of the compound proposition Ram is a man or Ram is a woman? Assuming that I am Ram, so Ram is a man is true. And Ram is a woman is what? Yes, it's false because Ram is a man is already true, right? So T, X, or F is equal to what? True. So the truth value of this compound proposition is true, according to this table, right? If the operator is conditional or implication, all the possible combinations are true except for this row. If the hypothesis is true and the conclusion is false, then the truth value is always false. The rest, true. For example, what is the truth value of the compound proposition if monkeys can fly, then 1 plus 1 equals 3? We all know that if we see if and then, this tells us that we have an implication or conditional statement. Now, if this is P and this proposition is Q, what is the truth value of monkeys can fly? We all know that monkeys cannot fly, so P is false. Now, is 1 plus 1 equal to 3? Of course not. So Q is also false. So the truth value of this compound proposition is now true. And it's written all over here. The last but not the least is the biconditional or double implication. This one is like the equal symbol. So if they are both true, then the answer is true. If they are both false, then the answer is true. So if they don't have the same propositional value or truth value, then they are false. For example, what is the truth value of the compound proposition 1 plus 1 equals 3 if and only if monkeys can fly? If we see if and only if, we know that this is a double implication or biconditional. If this is P, then what is the truth value of P? We all know that 1 plus 1 equals 3 is false. If this proposition is Q, what is the truth value of Q? We all know that monkeys cannot fly, so this is also false. And the truth value for F, if and only if F is true, because they are equal, right? So it's true. As mentioned in the introduction of this video, the truth table allows us to see all the possible truth value outcomes of a given compound proposition. And for us to identify the number of rows we need when constructing truth tables, we can use this formula. Number of rows is just equal to 2 raised to r, such that r is the number of non-identical propositions in the given. For example, if the given proposition or the given compound proposition has propositions p, q, and r, then r is equal to 3. So 2 raised to 3 is 8. So if we have a given containing P, Q, and R, we need to prepare a table consisting of 8 rows, excluding the label, okay? Excluding the label or the titles for the table. Now let's begin by identifying the number of rows for the table on this given. You can see here that we have two non-identical propositions, P and Q. This is another proposition, P, so let's just count it as this one, right? So we only have two propositions given P and Q. So since P and Q are 2, then it's 2 raised to R, which in this case is 2. 2 squared is 4. So the number of rows that we need is 4. So I have is here is 1, 2, 3, and 4. If we are given two non-identical propositions, we always use these combinations. For the first proposition, it could be double T and double F. Then we have TF, TF. We are doing this to find all the possible combinations of truth value outcomes. We also need to follow the laws of precedence of logical operators. If you want to have an idea about this precedence, please check out my other videos in the playlist entitled Logical Operators. By following the laws of precedence, we need to start with the P and Q. That is why here we have the first column as P and Q. Now, imagining that we have a conjunction here, what are the possible values of this first column? So T and T is true, so these three remaining cells are false because in conjunction, it's only true if the two propositions are true. The next operation will now be negation, and this time we need to negate the previous column, which is P and Q. So this time we just need to look at this column, P and Q. Now, by negating all these values, what are the possible values in this column? So the negation of T is false. The negation of false is true, and so on. After the negation, we proceed with or disjunction. And since we already got this one using this column, we just need to pair it with P. But this time, we need to refer to this column and to this column because this means we are operating or using P and these compound propositions. By putting this column here, what are the possible answers? So P or this compound proposition, so we have P, which is true here, and this F here. True or false, the answer is true because in this junction, if at least one of the propositions is true, then the answer is true. True or true is also true. False or true is also true. And the last one is also true. And that's how we complete the truth table for this compound proposition. And these four values here are the possible outcomes for this compound proposition. But do you know that we have an alternative solution for us to lessen our effort of writing long column labels here on the table? So to begin, you just need to separate each proposition and operators in a column. Following the pattern in the previous example, we have double T and double F for P. And since we have another P here, we will also write double T and double F here in this column. Now for Q, we're going to use our second pattern, which is TF, TF. But what if you place TF, TF in P and double T and F in Q? That's okay, we'll still have the final truth value outcome. And of course, we still need to follow the laws of precedence. So here, we need to have P and Q first. So comparing this column and this column, we'll have what? True and true, the answer is true. And for the rest are false. After getting this, we need to follow negation. And we need to negate this column, right? So we just need to look at this column because it's the answer in the previous operation. Now, the negation of true is false. the negation of these three values are all true. For the final outcome, since we already got the values for this compound proposition, which is in this column, we just need to pair it up with P. And in this example, it's this column. So we just need to look at this column P and negation. All right. So true or false is true. True or true is true. And following the same rule, we have true to all cells. We had the same results, right? All are true. Now, how about this example? Again, we begin by separating the propositions and logical operators using columns. Now, following the laws of precedence, we need to operate the values inside this grouping symbol or parenthesis. Now, as you can see here, I already placed the pattern for the proposition P and for the proposition Q. For P, I use double T and double F, and for Q, I use TF, TF. As I mentioned, you can always interchange these patterns for P and Q. Since negation precedes implication and conditional, we start with negating Q. So the negation of true here is false. The negation of F here is true. Following the same rules, we'll have these values. After getting the negation of Q, we need to pair this column to P. And we use the operation implication or conditional. Now, what is F implies T? F implies T is true. How about true implies true? That's also true. How about F implies F? That's also true. And how about true implies false? Well, this is false. Ang tinatandaan ko lang, pag TF, laging false. The rest, true. Pagdating sa implication and conditional. Since we're done with this part, which is this column, we're going to pair it up with this column, P. Okay, and this time we need to use the exclusive or XOR. Now remember that in exclusive OR, when the two propositions have same values, it's always false. So true XOR true is false. True XOR true again, it's false. But for true XOR F, this is true. And F XOR F, the answer is false. And this is now the truth table of this compound proposition. In this next example, notice that we have three non-identical propositions. We have here P, Q, and R. And for this, we need to construct a truth table consisting of 8 rows. But why? Because we have three non-identical propositions. So we're going to use 2 raised to r, or in this case, 2 cubed, which is equal to 8. That is why we need a table consisting of 8 rows. 3, 4, 5, 6, 7, and 8. And here we will change our pattern because we have 8 rows. So for the first proposition, you can use quadruple T and quadruple F. For the second proposition, you can use double T, double F, double T, double F. And for the third proposition, you can use the pattern true, false, true, false, true, false, and so on. The column Q here has the same value as the column Q here. And to begin, by following the laws of precedence, we need to negate Q first. So by negating this Q, we'll have our answer in this column. Here they are. After getting the negation, we'll proceed with conjunction. And this time we need to compare R and this not Q. So we're going to pair these two using conjunction. Now using this R column and this not Q that we got a while ago, we'll have our answer in this column. After the conjunction, we need to use the implication or conditional by pairing up Q and the answer that we got here. In this case, this column conjunction and the Q column here. Okay, so make sure not to include R here because we already got the values for this compound proposition using this column. So you just need to look at this Q and conjunction column here. By doing that and following the implication and conditional rules, we'll have these values. The last but not the least is the biconditional. So here, we need to compare this compound proposition to this proposition. So pairing these two using biconditional, we'll have what? This, we'll have to compare this column with this column that we got a while ago. So by following the biconditional rules, we'll have this final answers. And that's how we complete the truth table for this compound proposition without grouping symbol. Now that we are used to the values in the truth table, it will be easier for us to solve this kind of problem. Let P be the proposition there is no letter I in the word team. Q be the proposition 10 is divisible by 3. R is the proposition 22 greater than 13. Find the truth value of the following propositions. The first thing that we need to do here is to identify the truth value for each proposition. For letter P or proposition P, there is no letter I in the word team is definitely true because as you can see here, there's no I in this word, right? In Q, 10 is divisible by 3 is false. 22 greater than 13, well, this is true. Now that we know the values, we can start finding the truth value of this compound proposition. Okay, so here, P is true, so I'm gonna write true here. Q is false, so write F here. P is true, and again, Q is false here. We start with this group. So we need to negate P first, and the negation of true is false. Now, after the negation, we need to proceed with conjunction. Now, F and F here will give us the answer false. Okay, after the left side, I'm going to solve for the right side. So here, we need to negate F first. So the negation of F is true. After negation, it's conjunction. So true and true, the answer is definitely true. Now, what is left is this part and this part. And we need to pair them up using this junction. So F or true, the answer is true. So the truth value of this compound proposition is true. For the last one, we need to use R. So for P, it's true. For Q, it's false. For R here, it's again true. P is true, and here Q is false. How about I start with this group? And here, I need to start with this conjunction here. So true and F here is false. After getting false, I need to negate this by following this operator here. So we have the negation of f as true. After getting the negation, I need to pair this up with the value of r here using the disjunction operator. So true or true, the answer here is true. On the right side, this is just P implies Q. So what is T implies F? T implies F is false. So the answer here is false. Now that we're done with the left and the right side, we can now use symmetric difference here to get the final answer. And T, X, or F, the answer is true. So the final answer for this compound proposition is true.
And that's all for this video. If you want more video discussions in logic and math in the modern world, please like, share, and subscribe to my channel. Thank you for listening.